So one notice that I want to make is that in terms of the exercises on Monday, so this Monday, several other persons had stuff that they had wanted to go through in the session, but based on time, we couldn't do all of them, and I don't want you to miss out on bonus marks if you really want to bonus marks. And here's what I did. On the orbital site, anybody saw the extra forum? There's a forum there, I don't know what it's called, I don't know what I call it, but some people do class participation. So during the class session, you can upload your contribution to it. So you can upload a picture, an image. You can do it during the session, and you can also do it within the hour following the session. After that, then I won't consider it, because the bonus marks is really for your interaction at the time, right? Okay, so on to modeling requirements. So you know that we use use case diagrams to model requirements. The use case diagrams are a part of the whole modeling process. A model is more than a diagram. It's the overall representation of the view of the system that you're trying to do. So in a use case view, we need more than the use case diagram. We need a use case diagram because we need some type of descriptive element that goes with each use case. There are different things that you can do. One is that you can use activity diagrams, which we'll do next week. Another way that we can address it is to provide a narrative. And the narrative, there are many, many different forms that people use for narratives. Sometimes organizations develop their own forms. You can use scenarios. You can use a table format, which I'm going to show you with the specific fields. It can just be a sentence or two. So there are different ways that you can describe what happens in the use case. And you'll recall that we were very clear on Monday that use case diagrams are used to show what, not how. So the narratives are there to show how, right? Or the specification of the use case is there to show the how, to explain the how. So use cases are used to model requirements. Assuming you have requirements, because many times you don't really have detailed requirements. So assuming you have requirements, many times they are loosely stated. Some may overlap and it may not be at first glance very easy to communicate to the design and development team what the system is supposed to do. Use case diagrams are an easy way to flesh out what the requirements are, because anybody can understand a use case diagram. When you look at a use case diagram, provided it doesn't have a whole lot of extends and includes and inherits and all kinds of things, it's usually very easy to read, right? You don't really need to know a course to understand. Anybody can understand a use case diagram. Which is why, I think I told you on Monday, with modeling, we aim for simplicity. You don't, so this is kind of an aside from this morning's lecture, but it is relevant to the entire course. Sometimes we feel compelled to make our diagrams look very technical, because we're science people and tech people, you want the things to look technical. You must aim for simplicity. Do not add things that are not necessary, right? So when you look at the use case diagram, when you're doing a use case diagram, you want to think about the fact that you're talking to your clients, using it as a way to talk to clients, using it as a way to communicate to clients what you understand to be the requirements, and you're hoping that if your understanding of the requirements are off in any way, that they'll be able to contribute something to the diagram, right? So it must be simple. So use case diagrams give us an opportunity to, in a simplified way, express the requirements of the system. A use case diagram also gives us a method whereby analysts, developers, and customers can speak the same simple language. Everybody can use it together. Use cases help with iterative approaches to development, as we can specify on the use case diagram which use cases belong to different iterations. Remember on Monday, we had an example where we spoke about a particular use case, a particular user requirement that may or may not be developed in the future. We spoke about the fact that we can highlight that. The use cases help us to easily be able to say which things belong to what releases, or which things belong to what iteration or increment of the system. We can use a use case diagram to indicate the priority level and risk level of different use cases. Remember, when we looked at use requirements documents, for every requirement you are able to specify, or you should really specify a priority level. Right? Now, we use in the software engineering course, we use basically a modified version of an IEEE template. But there are other templates. And organizations sometimes create their own internal templates that they use that suit the kind of projects that they deal with. Right? And the types of teams that they use and so on. So as I said, practitioners can use different colors or put additional system boundaries. So within the big system boundary, you can have another boundary that covers some of the use cases to show that they belong to a particular release. So what is a use case? First of all, a use case is a situation where a system is used to fulfill one or more of your users' requirements. Remember last week I explained it has to be a complete, on Monday, sorry. It has to be a complete requirement. And we'll cover some of that a little bit later. A use case captures a piece of functionality that the system provides. Use cases guide the other elements of design. So usually, especially with object-oriented approaches and methodologies or processes like unified process for software development, the whole process is use case driven. So usually you start out with a use case, and from the use case comes about as you try to analyze, as you go into the requirements process. So you have your use cases, and then from there you try to develop. From there you start thinking about your architecture. And then the architecture very often is what is used to drive or to initiate the process of the deeper levels of design. So you look at your use case model, and there are some of your use cases which we call functional requirements or primary requirements, user requirements, that help us to figure out some of the minimum things that the architecture of the system must include. In addition to that, you look at things like your non-functional requirements. We spoke about this in 2140. You look at your non-functional requirements and you prioritize them. You try to figure out what's most important. Is performance very important? Is availability very important? And so on. And those things drive your architecture. Once you have your architecture, even for agile development processes, architecture is where, in agile development, we don't spend all the time on documentation, right? But usually it is very useful to have a documentation of your architecture. And that can be driven from this process where you have your user requirements. That architecture can be used to help you to figure out what components of the system need to be built, which components depend on other components, and therefore how you approach. Because remember, agile development says you want to develop complete parts. You want to have a running system after each sprint or after each iteration is complete. And so you want to look at you want to figure out what are the deliverables. How are you going to divide up the deliverables? And so the architecture is a good place to start in order to do that. So back to this. So they describe a system's requirements from the outside looking in. They should be developed early. You can't develop something if you don't know what you'll be required to do. In other words, you get use cases firmed up as much as possible early on. Yes, there might be changes, but you get them firmed up as much as possible early on. But you don't want to start developing and you're going in the wrong direction, right? Use cases do not capture non-functional requirements, nor are they used to say what the system does not do, only exactly what it should do. So, let's use an example to help us look at different parts of a use case model. So we're going to talk about a content management system that needs to be developed. Our first requirement, called A1, is the content management system shall allow an administrator to create a new blog account, provided the personal details of the new blogger are verified using the author credentials database. So, first thing I want to think about is in this requirement, who or what interacts with the system. Now remember, an actor may be a person or a system or other kinds of events that may occur outside of the system. Oh, I thought you were adding something. Okay, so our actor, first of all, the actor is drawn as a stickman. Always like that. You can also use the stereotype actor, that little thing, those little brackets we call them. We use them to stereotype elements in UML. Remember, we spoke about UML on Monday. I said to you that you can extend UML. Yeah? So you can add elements to UML. So if perchance you wanted a different type of actor, so one of the reasons that people use this is if the tool that they're using doesn't have this stickman in it. So they might just use a classifier. These rectangular boxes are called classifiers. We use them to represent classes, components, classes and components. And we just put the DME, the little brackets on the side, to tell us what's the type of the entity that we're introducing into the notation. So we can do that for actor. So requirement A1 contains an administrator actor that interacts with the system to create this block account. Now, how do we recognize actors in the system? So sometimes we'll have problems with figuring out who are the actors in the system. One of the things that happens sometimes is that we represent persons as actors. So if you're developing a system, let's say developing a document management system, and you happen to know that it's going to be used in an organization where there are 2 secretaries and a manager, and you have some line workers or something, and these different people are going to be using it. Sometimes persons will actually put the different positions as actors. So you might have secretary, office manager, and then do the connections to the use cases. If it is that the secretary and the office manager really are going to have the same role in their interaction with the system, you don't need to separate them. So you just need to determine roles. So actors on a use case that are used to illustrate roles in terms of interaction with the system, not positions in an organization, even though they might overlap. So not positions in an organization, and also not actual people. Sometimes people will actually put the names of persons there. And that's not what we use actors for, so it's roles. So it's learned through experience and practice, a simple technique for analyzing a thing in the requirement, and how to decide if it's an actor, we can do with this chart here. So a simple activity diagram or a flow chart. So the first thing is that we're trying to identify whether or not a thing in our requirements is an actor. We'll ask ourselves, is the thing an actual person interacting with the system? If it is, then it's very likely to be an actor, right? If the thing is not a person, then we need to find out if that thing is something that can be changed within the system's design. If it cannot change within the system's design, then that means it's a part of the system, so it's not an actor. Anything that is within the system or part of how the system functions and you actually have control over how it's going to behave in its interaction with the system is actually a part of the system. Does that make sense to everybody? Then that's not an actor. If you don't have any control at all, then that means that it is very likely to be an actor. So common actors that are not people, or that don't represent persons or positions in an organization, that are actually actors are time, external systems. So if you're building your system and the system has to provide a service to some other system, or that system needs to query your system or ask your system to do something or get some results from your system, then that is likely to be an actor. Sometimes it's a primary actor, meaning that it initiates the activity, initiates whatever it is that's happening. Sometimes it's not primary, sometimes it's secondary. But sometimes there is a primary actor and you'll see an example here. There's a primary actor that initiates a particular use case. But in order to complete the use case, there's some other system or actor that needs to participate. That's called a secondary actor. Actors can be related to each other, and I think we spoke about this on Monday. Everybody understands the use of inheritance in relation to actors. Hello. Okay, so I understand that, let me just pause a second. I understand that there's a clash between systems. Anybody here from systems programming? We saw, Dr. Miller wants to go to class today. They're trying to resolve the clash. So he needs everybody there. Class is being recorded. My class is being recorded. So we can go and then come back. But where is it? I don't usually go to that class. If you're registered for that course and you're missing it now, don't miss it today because you want to get everybody's feedback so that he can resolve the clash so that next week we don't have the problem. Right, so what do we use? In what situation would we use inheritance between actors? Yeah, let's talk about that.
Like now an actor, I believe I have another actor that is going to receive it.
Right. So if you have two actors, and both of them carry out a similar common set of core functionality, or they need to have access to a common set of use cases, but one of them carries out some additional ones. Then you get the one that carries out the additional ones inherit from the first one, and they add the additional use cases. Right? Alright, so now we just spoke about actors. Now we're going to talk about use cases. Use case diagrams are very simple. There's not a lot to talk about. The main thing is to practice and to understand the rules. It's very, very simple. So actually finish talking about actors now. Are there any questions about actors? Any problems anybody has when they're trying to draw use cases where actors are concerned?
The inheritance for the actor, so that we have a normal person and then we have an administrator. If the normal person is able to do three things and the administrator is able to do one more thing and inherit from the normal person, but that normal person has the 3 hours limit for use cases, right? Do you have to draw the hour from the administrator to do those 3 hours?
No. It implies it. You're correct. That's good. So the question is, if you have set up an inheritance relationship to demonstrate that this normal actor has 3 use cases or is associated with 3 use cases, and there's an administrator, for example, that inherits those 3 use cases, do you draw the line just from the administrator just to the extra use case, or do you also draw the line to the use cases that are inherited? The answer is that you only draw the line to the extra use case. The purpose of the inheritance relationship in the use case diagram, inheritance in use case is completely different from inheritance in class diagrams or programming. Totally different idea. The purpose of the inheritance relationship here is to cut down on the clutter on the diagram. That's basically what it is. And to also helps to give highlights user roles and user the hierarchy of how you allocate permissions, how you design the system to give different levels of access to different functionalities. It kind of brings that out. But yeah, we don't draw the lines again. Alright. Once you have identified an initial set of actors that interacts with your system, you need to identify use cases, obviously. Right. And these are the cases where the system is performing a specific job for an actor or actors. So, what is a use case? Tell me what you understand to be a use case. How do you go about, like for example, when you got exercise on Monday, or when you practice on your own, because I know you practice on your own, how do you go about identifying use cases? functionality that has to be provided by the system, achieved by the system. Okay, when interacting with an external entity like that. Anything else? That is the same definition everybody else has, the same exact definition. More or less, same idea. Right, so it's a goal that an actor has when they interact with the system. Alright, so each use case can be identified from the requirements, turn requirements into a clear set of jobs for the system. Some use cases are simple, such as login. Others are more complex, such as perform transfer between different bank accounts. A use case is a complete, notice this part in red? I added this because I realized this is a major problem. A use case is a complete use of the system. There is interaction from the system to some, and some results of the interaction. One thing that I want to highlight for you, and I hope it will be clear, is that use cases do not represent steps or functions, sub functionalities. It has to be a complete goal. So I want you to give me, just randomly anybody, give me an example of a use case. No man, it's only, okay, so later on I'm going to talk about naming use cases. A use case, the name can have more than 3 words. We should have about 2 words. Or one at a time. What's yours? Okay, you're stealing mine. 10 years. Check out? Check out what? Check out book. Okay. What's yours? Huh? But blog account is really, they're not as good as me. This is from Miles. But the point is that the phrase should have, say, create a new blog account, or you can just have create blog account. You don't need the annual part. But the point is, I want you to understand that it's a short phrase. You don't describe anything in it. So you don't say create an account by doing this or for so and so. You don't say all of those things. It can be more than 2 or 3 words, but you really want to make the words a short amount, must be very, very succinct. And the first word, as I'll show you later, the first word should always be a strong verb. Yeah? A very strong verb that makes it very clear what you're talking about. Give me some more. Update account. Update record. Create client form. Okay. Delete record. Anything else? What does that mean? Calculate transaction. Alright, calculate transaction. Okay. Any more? Make deposit. Alright. Somebody right here. Someone here or something? Well, that's all they do. Create client form. Alright, I want you to tell me the context within which this form is being created. Why are you creating a client form?
It's a form of the register in some as an input, so combination.
Say creating a form? Submit client form, okay. So where the client form came from? So is it like we can go to the system with the form in your hand and this? So I'm just trying to figure out where the form came from. Okay. Can you submit the client form without putting in the client details, for example? Okay. Is there ever a time when you can, because it may be that the system is designed that way, is there ever a time when you want to submit, because by submit you mean like save the data or save things, right? Okay, so is there a time when you would just utilize the system registration or signing up. That is what the use case is. Those other things are steps in the use case. Did everybody hear that conversation? I hope it got recorded. That is the problem that I have seen with use cases, that sometimes, because as a programmer, these are important functionalities for you to write, but the use cases are not the same as those functionalities. The use cases are business goals. That's a good way of thinking of it. They tend to be more like business goals. Remember when you did software engineering and you wrote the user requirements? Remember the user requirement, when you were writing a functional requirement, Mr. Anderson told you to break it down into two parts. You had a user requirement and then you had some details. Those details are not use cases. You see the user requirement, those generally translate into use cases. The details below are system requirements, and they're like the way in which the system is supposed to be designed to make those things happen, make the use case happen. We don't put those as use cases. However, when you detail the use case, when you specify the use case, like what I'm going to show you later, some of those things will come up. The whole thing of, oh, you're going to enter this and then you're going to submit that. So intern information is not really a use case because people don't usually have an interest in intern information. Like, when was the last time you were like, I really just want to put in my information today? Like, which system can I use to do that? You tend to want to register for a system, or you want to add a record. You don't like set yourself, today I want to save a record. You just want to save. Let me go to the system, let me log in and save. You want to log in to create a record, or to add a record, or so that's how you have to think about the use cases, alright guys? So what makes a good use case? Again, experience is probably the most important fact. You have to practice. Think about systems that you know and just practice the use case models for them. A simple rule of thumb can help. A use case is something that provides some measurable result to the user or an external system. Saving is not usually a measurable result to the user. The user wants to add some data or add a record or edit something. Saving is something that is a step in that process. Can your use case pass this test? If so, then most likely you have a good use case. Communication lines. Sometimes they call them association lines. The lines between the actors and the use cases. So we use these communication lines to show that a particular actor is involved in a use case. We do this by drawing the connecting line between the actor and the use case, and you all are familiar with that. You notice that I don't have any arrows there? There are rare cases where you need arrows, and that tends to be when we have secondary actors involved. So, but usually you don't have any arrows between actors and use cases. It's implied that it's the actor that's initiating the use case. Sometimes you want to show that sometimes you want to show that the actor is secondary and that there's some results from the use case to the actor. But in general, though, we don't use arrows. It tends to cause us a confusion because it suggests, sometimes these arrows suggest, it gives a sense that data is being passed or some object is being passed, and that's not really what necessarily is happening, so we don't use arrows. Okay. So we use communication lines to show that a particular actor is involved in a use case. We do this by drawing the connecting line, as we said before. No navigation is necessary to indicate initiation. System boundaries can be used to make even more clear the separation between the system being considered and external actors. This says it can be used. I would say it must be used. In this course, you must use your boundary. You must make it very clear that you know that some things belong in the system and that these actors are outside. The boundary lines are also useful, as we said before, for helping to indicate, you can use it to indicate what use case is also completed in a particular increment. You can also put you should also put the name of the system that you're talking about inside the use case, inside the boundary. If you're building a big system and it has like subsystems, you can do different use case diagrams for those subsystems. For the systems that you're developing, they are not that big. If it's just, you're really only going to be developing one system. So you should only have how many use case diagrams? Only one. Alright? Now descriptions. The diagrams don't give enough detail by itself. So for instance, you look at the diagram, you get a good sense of what system should do. But for the purposes of a designer, the person who's going to design the software, more information is needed, right? So you want to convey more information to system designers, in other words, help them to have an idea of how the system will need to or should accomplish the use case. Every use case should be accompanied by a text-based description. This can be a paragraph or two of text, SS style, or it might have distinct parts listed or tabulated. So this is an example of some of the fields that we might use now. The template that I'm showing you, you can use this template in this course if you want to. You don't have to. Alright, you can do your own research and find another template that you like. This is a simple template and you could use it for the course. So, related requirements, goal and context. So, related requirements, some indication as to which requirements this use case partially or completely fulfills. Recall that in your requirements document, you can show the relationship between user requirement and a particular use case. Same thing here, you can specify which requirement is related. Goal in context. Use case is placed within the system and why the use case is important. Preconditions, what needs to be true before the use case can be executed. What needs to be in place first. Successful end condition or post condition. What should the system's condition be if the use case executes successfully? You can also provide a failed end condition. What the system's condition should be if the use case fails to execute successfully. You can provide a list of primary actors. Who are the actors that are interacting with this use case, who are going to be using the use case? So primary and secondary actors. Secondary actors are actors that participate but are not the main players in a use case's execution. And you'll see an example of that. Trigger, the event triggered by an actor that causes the use case to execute. Main flow, the place to describe each of the important steps in a use case's normal execution. And then extensions are alternative pathways that a use case can get, like branching actions. So like where you have if-else statements in your code. You don't have to use all the fields. So even in the context of us doing our project, if you even want to use this template, you don't have to use all the fields. I don't know, can you see this? Okay. So this is an example. Create new blog account. Remember, we're looking at a blog account, a content management system. And this is the use case, create a new blog account. The related requirement is requirement A1. Remember, we saw that requirement at the beginning of the lecture. The goal in context, a new or existing author requests a new blog account from the administrator. So it tells us why is it that this is our goal, right? What's the context within which it is needed? What preconditions exist? The system is limited to recognized authors, and so the author needs to have appropriate proof of identity. So before this use case can be executed successfully, we need to prove that we need to check to verify the identity of the particular author, right? Failed end condition, the application for a new blog account is rejected, and the successful end condition, I skipped that, is that a new blog account is created for the author. Primary actor is the administrator, because the administrator is the one who initiates creating a new blog account. So an author can't create their own new blog account. I guess maybe there's some request that is sent, yes. So there might be another use case that is initiated by an author, even though we don't discuss that here, where a request is sent. If that's a part of the system, maybe that's manual, but that's not a part of the. You have to be a little bit louder.
So that author will execute and the registration is sent to the administrator who validates the registration. The administrator of the system.
Okay, so let's look back at the requirement that was started off with. Let's look at A1 and see what it says. Oh, that's a good question. Oh Lord, that's far. Here we go. The content management system shall allow an administrator to create a new blog account provided the personal details of the new blogger are verified using the author credentials database. Right. So what do you think the author credentials database is?
Is it a system itself interacting with the system that you have?
Right. So it's an external system. It's an external system. The way that it's stated now, it could be, you could have a null. So when people see this example, the next thing that I see is that all the systems always have an author credentials database or some database that they use for everything. And they always have it as external. If you're developing your system and the author credentials database is a part of what you're developing, then you would not put it as an actor outside.
How would they show it that it's within the system?
It would just be a step in the description for A1.
So if it is outside, how would they make it a use case within the system? And then relate that use case to create a new that is outside.
How do you make what a use case? The author credentials database?
It's a valid registration.
It's not a use case.
I mean, all the database system as an actor, it has to verify the registration it's right?
Right.
How would they show the verification as a use case and then
The verification can be a use case. How do I put it? I shouldn't say the verification, but the author credentials database wouldn't be a use case. Okay. So you want to know how you'd show the verification process as a use case. Okay, so if you're going to show the verification process as a use case, you just draw an ellipse and put it in there. Verify credentials or whatever.
and then how would they relate that to the
Mm-hmm.
administrator actually creating the product?
So you will have to decide whether it's going to be a use case. I'm going to tell you in a little bit as we go further. You have to figure out if it should be a use case or it is just a step within a use case. How you'll know that it's a use case is if, for example, all right, so on its own it wouldn't be a use case because there would be no outside actor triggering it. But if it is that you want to reuse that use case in multiple use cases using include relationships or extend relationships, then you can separate it out as a use case. And I'll talk about that a little bit more in a while. Right? But good question. I'm sorry. Oh, it's really fast. Oh, no. Oh, the animations are so all right. So we're looking at this use case, and we can see that we have a main flow, and we can see a demonstration of what the steps are. Now, you don't have to do it this way. Sometimes people write it as like algorithmic. You can actually say what the steps are like without the numbers. So we use the numbers sometimes because it allows us to be able to reference the different steps and to say go back to this step or go back to that step and so on. So the first step is that the administrator asks the system to create a new blog account. The administrator selects an account type. The administrator enters the author's details. The author's details are verified using author credentials database. New blog account is created. A summary of new blog accounts details are emailed to the author. Branching action are these. So if you look back at step 4, we see that check for the author's details being verified using the author credentials database. This is the normal exit path or the normal path. This is the extension. This is the branching action that occurs if this check was to fail, right? You can put additional notes, like for example on the branching action here to explain what would cause it to happen. All right. So this is just that you have an idea of how you use the different fields. And as I said, you don't have to use every single field. And you can modify the fields. You can look at other templates and see what you like and so on. Now, we need to refine the use case diagram because while we're writing the specification for the create a new blog account, while we're writing the specification, we realized that there was an external system involved. And so we add this new actor. So this was what we had before. We update it with the author credentials database. So we have the administrator and we have the author credential database, and we know this is actually a secondary actor. If you look back at this table, since secondary actors, author credentials database, because it doesn't initiate. And you usually can only distinguish between the primary and secondary by two things. One of them is that we tend to put secondary actors on the right-hand side of a use case diagram and primary ones on the left side. But that's not like a rule, it's just a practice. And the other way of recognizing it is by looking at the specification. So, and also just by, intuition. You would not expect the author credentials database to go ahead and start verifying. So there's nothing about creating a new blog account that would suggest that the author credentials database would be initiating it. So you'd realize this is primary and this is secondary. So it's intuitive, yeah. Hmm? Because we haven't reached there yet. So we have not identified verifying your ready notes. You ready notes before you came to class? Very good. So we haven't reached, just based on how I'm going through the thing. But yeah, if initially we haven't identified that particular process as a use case, we're going to identify it as a use case because later on we'll realize that there are multiple use cases that use those steps. That's the only time that you just pull out something and put it as a use case by itself, even though there's no actor initiating it, right? Well, in this case, we'll have a secondary actor initiating it. All right, while doing use case descriptions, we might find that one use case is similar to another. So this is where we're going to talk about use case relationships. This is where we're going to talk about our include, extend, and inheritance that everybody likes, right? So we can find sometimes that one use case is similar to another. Sometimes we can find that some use cases work in several different modes or special cases, and sometimes we find a use case with multiple flows throughout its execution. If we find that a use case is similar, so our use case covers the steps, or a use case is very similar to another use case, then it means that we are actually repeating, in the specification we are rewriting the same steps. So step 1, 2, 3, 4, 5 might be the same in two use cases. So you can pull those out and create a use case to carry those steps, and then you just include that use case in the original two use cases. Does that make sense? Right. So that's where our include relationship comes from. So these steps, these solutions here match to these problems. The other one that was said is that we can find that some use cases work in several different modes or special cases. And that is where we use. That's where we use no. What? What? I'm sure I heard X inheritance or others. Not extend. We don't want to show specialized behavior between use cases. The triangle. Inheritance. You know that inheritance is also called generalization, specialization, right? That's another way to describe inheritance. You have a general class or a general entity and you want to specialize it. With use case diagrams, you need to understand that inheritance between use cases does not imply that there's going to be inheritance. There's going to be a class and subclass relationship that maps directly to this when you're programming. The purpose of it might suggest that sometimes, but the purpose of inheritance between use cases is basically for you to indicate that there's a particular general type of behavior, and then there are specialized use cases that are very similar. These are similar, but you have some specialized ones. That's the main thing. It's really just telling the developers and the designers that this is something to think about. We're just identifying that there's similarity. That the process of registering, because remember, use cases are processes, they're not processes, they're goals, they're actions. Classes are nouns, right? Classes are objects. Classes represent entities. Use cases represent processes. So it may not be that because I said to you that, hey, we'll have a registration use case, but we'll also have 3 specialized versions of it. We'll have register undergrad, register postgrad, register special students. The only thing that I'm saying is that there are very similar processes, but within the business, remember that these are like business processes. There are very similar business processes, but there are some distinct differences that need to be addressed. So it kind of highlights to the person who's writing the code or designing the system that we can make use of we can do some reuse right here. When they're writing their program, they can take into consideration that code reuse might be useful. It doesn't necessarily suggest that the way that you'll approach the code reuse is inheritance.
Special cases, what is those special cases with optional cases? Like with the card machine, it said if the kid is entering wrong, you can destroy the card. But that doesn't make sense.
Okay, hold on. Which video? Oh, the video. Oh, right. Right. Go ahead again.
It said if the kid is entering, you can say anytime destroy the card. It was an extent, so that was an option. So that's why I was saying the special cases, it was that make sense.
No, those are what you're describing as a branching behavior, which is really an extends. What that is saying is that there's one process, but in that process, if a certain thing happens, you go this way, but if another thing happens, you go that way. This is not saying that if it depends on how you interpret it. If you decide that registration of a customer or whatever is a process, and there are 3 distinct processes that are similar, specialized processes, then it's not really a branching action. It's not like because of something unexpected. So you tend to use extends when you have a situation that is, you can't predict it. You can't predict it. There's something that's going to happen in the course of normal behavior, and then you're going to say, well, if it happens, you do this. Whereas with extends, with the inheritance relationship, you're actually saying that there are these 3 unique business processes. You know about them before, and you know exactly what is to be done in these 3 unique business processes. And from the beginning of the business process, you know which direction you're going. But you just want to be able to highlight the fact that these business processes are very similar in some ways, but they are very distinct elements to them. And that's when you use inheritance. Does that make sense to you? Right. So extend is used to show optional flows. So within the course of the behavior of the process, you have optional flows.
They said that using included, if you notice that some steps for instance, for example, inheritance, general registration, postgrad, special statement. Why we use inheritance there instead of just
Because, okay. So you use include if it is that, like, let's say the business processes are not the same. So for instance, editing a record is not the same as creating a new record. They are 2 very different business processes. Would you agree with that? But both editing a record and creating a record requires saving. Requires saving to the database or updating the database. So because of those steps, so after you do the process, the steps for creating a new record or editing a record, the last set of steps are going to be, for both of them, you're going to have retrieve a file or open the file and do this and do that, and some things that have to do with database and security for the database and so on and so forth. All those steps are common. So take those steps out of both of them and put them in a single use case and then include them. So what you have to think about is the business process. Use cases are not like programming. Use cases are business processes, business goals. That's what you think about use cases. And remember that use case doesn't always tell you exactly how to. These relationships, although they look like things from programming, so extend looks like something from programming, inheritance looks like something from programming, include looks like something from programming, but it's not the same. Alright? Any questions about that? So you guys are going to do some in studios next week. And that will help us get our practice going, right? What we'll do in the studios is that, because each studio will have about 5 or 6 projects. So what we'll do in the studios is we'll do them for every project, so you get multiple opportunities to practice and you see different kinds of situations. I think that sounds good, right? So we don't just, I'm not gonna just let you do one. I think how we did it last year was that I gave a problem, but I think if you do all of them, you're gonna change up the studio, so you get to practice a few. Alright, relationships between use cases, facilitators breaking the system down into manageable chunks. I don't want to go through this because we just spoke about it. So include is what we use when there are steps that we want to reuse in multiple use cases. Do not use include if you don't have another use case to reuse the steps in. So in other words, I saw on Stack Overflow, I saw somebody asking a question. The question was, I think Stack Overflow. The question that they were asking was if they have a use case A, and then they have use case B and use case C. Use case A uses use case B. I don't have enough time. I should have connected my thing. But use case A uses use case B, and use case B uses use case C. And then they were asking if use cases need to have, who are the actors for the use case B, who are the actors that initiate use case B and C? And the issue there is that the person is actually pulling out steps from use case A and separating them out as a separate use case without the need for either another use case to use it or another actor to use it. The only time that you're using include is if there's another actor or another use case that will utilize that use case. So what I want you to do is just go through the rest of the slides. They're almost finished. And just look at how we modify, because you're familiar with include, extend, and inheritance already. So I just want you to look at how we modify the narrative to take into account those changes. All right? Any questions before I stop?